In section 3.2, we will talk about independent and mutually exclusive events. So let's start with the definition of disjoint or mutually exclusive events. Events A and B are disjoint or mutually exclusive if they cannot occur at the same time. Here are some examples that are disjoint or mutually exclusive. Event A is randomly selected someone who's a Democrat, and event B randomly selected someone who's a registered Republican. A and B are disjoint. Why are they disjoint? Because they cannot occur at the same time. Event A, flipping a coin once and having it land on heads. Event B, flipping a coin once and having it land on tails. A and B are disjoint because, again, they cannot occur at the same time. You can't flip a coin and get both heads and both tails. Course grade, this is an example of an event that is disjoint. You can only get one grade. You can't get an A and an F for the same course at the same time. Here are examples of events that are not disjoint. A, randomly selected a student who's taken a stats course, and B, randomly selecting a student who's taken a business course. These are not disjoint because they can't occur at the same time. The student we select could be taking a stats course and could also be taking a business course. So once again, events that are not disjoint are events that can occur at the same time. Here's another example. Event A is rolling a die once and getting an even number. Event B, rolling a die once and getting a number that's greater than 3. These events are not disjoint because you could get a number like 4. Okay, 4. This satisfies event A because it's an even number, and it also satisfies event B because it's a number greater than 3. So A and B are not disjoint because they can occur at the same time. Hobbies are definitely disjoint events. Somebody could enjoy tennis and somebody could also enjoy swimming. So A and B could occur at the same time. Here are some other notes. The complements the complement of A are always disjoint. They cannot occur at the same time. When two events A and B are disjoint, then the probability of A and B occurring is 0, because remember, disjoint events are events that cannot occur at the same time. Well, if they cannot occur at the same time, that means that their probability of occurring at the same time is 0. Let's talk about the addition rule. To find the probability of event A or event B occurring, we would use the following formula. The probability of event A or event B occurring is equal to the probability of A plus the probability of B minus the probability of A and B. If A and B are disjoint events, then recall that the probability of A and B occurring is 0. Disjoint means, once again, that they cannot occur at the same time. So if they're disjoint, they cannot occur at the same time, so the probability of that happening is 0. So the probability of A or B is the probability of A plus probability of B, because if A and B are disjoint events, then the probability of A and B is equal to 0. Here's an example. Here's a pre-employment drug screening test for 1,000 employees. So the first row here is that the subject uses drugs. Now, the first column is that the subject got a positive test result. So the way we would read this is the subject uses drugs and got a positive test result. The second column here is that the subject got a negative test result. So the subject uses drugs, but they got a negative test result. This is called a false negative. This is called a false negative because the result was negative. However, it's a false result. The second row, subject is not a drug user. And even though they don't use drugs for whatever reason, they got a positive test result. This is called a false positive. That they don't use drugs, however, they falsely got a positive result. The second column here is the subject is not a drug user and they got a negative drug result. So that's a true negative. And these are just the totals from the two columns, and these are the totals from the rows. And at 1,000 is the total number of employees that were screened. Okay, now, if one subject is randomly selected from the 1,000 subjects given a drug test, find the following probabilities. In part A, we want the probability that the one subject that we select randomly got a positive test result or the subject uses drugs. So let's think about what that means. The subject could be someone who either gets a positive test result, so they could be in this column, okay? They could either get a positive test result or they use drugs. So we want the subjects that either got a positive test result or use drugs. So the subjects from this column, the first column, and the first row. Now the problem is this 44 is overlapping. Okay, so let's look at the formula. The formula for positive test result or using drugs is the probability that the subject got a positive test result plus the probability the subject uses drugs minus the probability that the subject got a positive test result and uses drugs, because we don't want to count that number twice. Okay, so let's go ahead and figure this out. What is the probability that a subject got a positive test result? Well, the total number of subjects that got a positive test result is 134. And how many subjects are there total? 1,000. So this is 134 over 1,000. Now, because we're using OR, we have to add the probability of the second event, which is subject uses drugs. So how many subjects use drugs? 50 subjects use drugs. And what's the total? 1,000. That's 50 over 1,000. Minus the probability that the subject got a positive test result and the subject uses drugs. So the subject uses drugs and got a positive test result. There are 44 such subjects. So we would subtract 44 out of 1,000. So when we have the common denominator, we would write the denominator as 1,000. We would add 134 plus 50 minus 44. And this gives us 140 over 1,000, which in decimal form is 0.140. So the probability that we select one random subject and they either got a positive test result or they use drugs is 0.140. Now the reason we subtracted this 44 out of 1,000, because let's see what's happening. The subject who got a positive test result, that's 40 plus 90, that's how we get the 134. The subjects who use drugs, 44 plus 6, we got 50. But we counted 44 in the column and the row, so we have to subtract off one of them, which is why we have a minus 44 out of 1,000, since we counted those twice. Here's another example. The probability that the subject is not a drug user or got a negative test result. Okay, so let's simply apply the formula. The probability for OR is the probability of the first event plus the probability of the second event minus the probability of the first and the second event. Okay, so the probability that the subject is not a drug user. Well, if the subject is not a drug user, then let's look at this second row. Subject is not a drug user. We got 90 plus 860, which is 950. So 950 out of 1,000 people are not drug users, plus the probability that the subject got a negative test result. So the probability of the subject getting a negative test result, if you add these, is 6 plus 860, which is 866 out of 1,000. But look what happened. If you add 90 plus 860 to get 950, if you add 6 plus 860 to get 866, 860 is being counted twice, so we have to subtract 860 out of 1,000, which is the probability that the subject is not a drug user and got a negative test result. So if we simplify this, this will give us 956 out of 1,000, which in decimal form is 0.956. So if we select a random person out of this group of 1,000 people, then there's a 0.956 chance probability that they're either not a drug user or they got a negative test result. Finally, the probability that the subject is not a drug user who got a positive test result. So the probability the subject is not a drug user, that's going to be this row, and got a positive test result, that's going to be this row. So those are 90 such people. So 90 people who took the test are not drug users and they got a positive test result. So that's 90 out of 1,000, which in decimal form would be 0.090 or just 0.09. The next example, please try on your own, and we will go over this in class. All right, let's do a couple more examples. 35% of all homeowners in a large town hire someone to maintain their yard. 12% of owners hire someone to clean their home. 9% of homeowners hire someone to maintain their yard and home. So A, what is the probability of randomly selecting a homeowner who hires someone to maintain their yard or clean their home? Now, when you see this word or, you got to apply the following formula. It's a probability of the first event, which is that they hire someone to maintain the yard, plus probability of the second event, that the homeowners hire someone to clean their house, minus the probability of both events happening at the same time, so maintain yard and clean home. So what's the probability that the homeowner has someone to maintain their yard? That's 35%, or 0.35. What's the probability that a homeowner hires someone to clean their house? That's going to be 12%, or 0.12. Minus, what's the probability that the homeowner hires someone to maintain their yard and clean their house? So 9% of homeowners hire someone to maintain their yard and home, so that's going to be minus 0.09. If we take 0.35 plus 0.12 minus 0.09, our answer will be 0.38. What is the probability of randomly selecting a homeowner who has neither hired someone to maintain their yard nor clean their home? Well, okay, let's think about this. The probability that the homeowner hires someone to maintain their yard or clean their home is 0.38. So the probability that the homeowner has neither someone to maintain their yard nor clean their home is going to be 1 minus 0.38, which is going to be 0.62. Because this is the probability that it's one or the other. So for it to be neither, it can't be one or it can't be the other. So it's going to be the complement of the first event, which is going to be 1 minus 0.38, or 0.62. Okay, let's do one last example. What is the probability of randomly choosing a heart or a queen? Well, because we have the word or, it's a probability of the first event, which is choosing a heart, plus the probability of the second event, which is choosing a queen, minus the probability of a heart and a queen. So here's the deck of cards laid out. How many hearts do we have? We have 13 hearts. And how many total cards do we have? We have 52 total cards. So the probability of choosing a heart is 13 out of 52. What is the probability of choosing a queen? Well, we have 1, 2, 3, 4 queens out of a total of 52 cards. What is the probability of choosing a heart and a queen? Well, there's only one heart that's a queen, so it's going to be minus 1 over 52. If we simplify this, this will give us 16 out of 52, or 0.307. So the probability of randomly selecting one card and the card being either a heart or a queen is 0.307. Okay, last part. What is the probability of randomly selecting a face card or an ace? All right, so this one, work on this and we will go over this in class. Remember to apply this formula. Event A or event B minus the event A and event B. You can work on the next example on your own as well, and we will go over this in class as well.